Okay, right? Welcome to the session. See here, the question given is the operating point variations. The operating point variations due to IC0, VBE, beta, all the above. What is the correct answer for this? Yeah, right, ma. So generally what happens is your operating point variations are due to beta it will vary, due to VBE it will vary, due to IC0 it will vary. Sir, IC0 how it is varies? IC0 is depends upon temperature. VB is also depends upon temperature. So actually IC0, what happens? IC0 is doubles for every 10 degrees centigrade in rise. So it is like, it rises by doubles for, it is a double for every 10 degrees centigrade in rise. Sir, how the VB is affected with temperature? The answer is D is okay. How the VB is affected for temperature? The VBE value is decreases by 2.5 millivolts per degree centigrade. It is decreases, that's why we can call minus. We can denote with minus. Minus 2.5 millivolts per degree centigrade. Like that. So what about this one? What about this one? What about beta? Beta is mainly depends upon what? The beta is mainly depends upon manufacturer. One manufacturer to other manufacturer, the beta may be depends upon temperature, but majorly the beta is affected due to what is that? Manufacturer. One transistor to other transistor, these values may be different. That's what we have. So whenever if you are reading one question, try to get the maximum information. So what is IC0, what is VB, what is beta, how they dependence, all the points we have to learn, we have to understand carefully. Right. The next question. Yeah, tell me. The stability factor of a fixed bias is. The stability factor of a fixed bias is 1 plus beta, 1 minus beta, beta by 1 minus beta, 1 by 1 minus beta. No. Bhuvan, beta is mainly depends upon the one transistor to other transistor. It is actually, it will be double for by rising 75 degrees centigrades. So what is the stability factor for a fixed bias? Yeah, Santosh. Right, Rajesh. For stability factor for a fixed bias is 1 plus beta. Stability factor for a fixed bias is 1 plus beta. What is the stability factor for a potential divider bias? For self bias. For self bias, what is the stability factor? S is equal to 1 plus beta divided by 1 plus beta into Re divided by Re plus R Thevenin. Re plus R Thevenin. This is the stability factor for a self bias system. Self bias is having less stability factor. It has a better stability. This one is having better stability. In case of collector to base bias, here RC by RC plus RB we are getting. RC plus RB we are getting. Okay? Right, Amma? Next. What is next? The resistance of the thermistor decreases exponentially with increasing of temperature, decreasing of temperature, both A and B. None of this. Thermistors. Thermistor you have to read carefully. Thermistor. So thermistors, what they have? Thermistors are having negative temperature coefficient of resistance, NTC. Thermistors are having NTC. Negative temperature coefficient means when temperature increases, resistance value decreases. Temperature increases, resistance value decreases. Whereas if it is a sensistor, sensistor is having PTC. There if the temperature increases, resistance value is increases. Sensistors are different, thermistors. Thermistor and sensistors are opposite type. So decreasing of temperature. Are you okay, ma? Thermistors are having PTC. Thermistors are having NTC, sensistors are having PTC. Right? Next. Yeah. Similar type of question has came. Which one of the following has a negative temperature coefficient of resistance? Negative temperature coefficient of resistance. Just now we discussed that one, that point. Again the point has came. Which of the following is having negative resistance, negative temperature coefficient? Thermistors are having negative temperature coefficient of resistance. Sometimes the examiner may confuse you. Negative temperature coefficient of resistance is nothing but a positive temperature coefficient of current. Negative temperature coefficient of resistance is nothing but a positive temperature coefficient of current. That's what we have. Next question. Yeah. Which of the following has positive temperature coefficient of resistance? Sensistors are having positive temperature coefficient of resistance. That point already we discussed without seeing this question also. For normal amplification, Q point should be established in the active region, saturation region, cutoff region. So always the Q point should be placed in an active region only for amplifier purpose. That is middle of the load line. Middle of the load line. Next. Next, what is that? The The following biasing techniques gives good stability. The following biasing techniques gives good stability. Collector to base bias, fixed bias, self bias. This is a very important question, Amma. Which is having best stability? Self bias is having good stability. Stability factor. This is good stability for self bias. This is a very important question. You can. This will be the expected question in the exams. Next two. Actually, stability factor yes is approximately unity for collector to base bias, fixed bias, self bias. Always the stability factor should be near to 1. Should be near to 1. That is possible in the case of self bias. Of course, 1 is not possible. Even the stability factor may be 7, 10 or in that range basically. But only probability is this one. Which one? Fixed bias, self bias will have better stability factor, so that we can take as that. What is a fixed bias? Not fixed bias. What we are talking? Self bias. Are you okay? Now see here, what is the question? The following transistor parameters is a function of temperature. Beta alone, IC not alone, VBE alone. I told you now already. IC naught is depends upon temperature. VBE is depends upon temperature. Beta is also depends upon temperature. So that answer is all the above. Most of the cases when all the above will come, I think you are going to answer that one only. Which of the following statement is true? Both IC naught and VBE increases with the temperature. Both IC naught and VBE decreases with the temperature. IC naught increases and VBE decreases with temperature. In the first slide itself, when I started this class, in the first slide itself, this statement I already told you. IC naught is increases and VBE decreases with temperature. IC naught is doubles for every 10 degrees centigrade. VBE decreases by 2.5 millivolts per degree centigrade. But already we discussed now. IC naught is increases, doubles for every 10 degrees centigrade. VBE decreases by 2.5 millivolts per degree centigrade. That's why answer is C. Answer is C. In transistor, heat developed at the collector junction may be removed by in power transistor, the heat developed at the collector junction may be removed by the use of heat sink. Use of heat sink. Transistor which is high beta, transistor with low beta, none of this. Tell me what would be the answer for this? Very simple question, na? Yeah, heat sink only be the answer. No, yaar, heat sink is the answer. The name itself it has answer. Sink. Sink is a absorber. Heat sink. Heat is removed. Heat sink is required. A is the right answer. Right, ma. Next two. This is also a very good question. The condition to prevent the thermal runaway. The condition to prevent the thermal runaway. The rate of power dissipated at the junction should be less than the rate of heat generation should be less than the rate of heat dissipation. What would be the answer for this? The question. Yeah. dPc by Pj is less than 1 by theta. This type of questions will come. If you can able to answer it, you will get a good marks. You will get a good marks. Rare questions, sometimes they will ask you, but you are going to get this. Are you okay? Next. The rate of power generation should be less than the rate of heat dissipation. That is the condition. Self distortion of unstabilized transistor is known as biasing, stabilization, thermal runaway, neutralization. Tell me what will be the answer? Very interesting question, huh? Very interesting question. What is that? Self-distortion of unstabilized transistor is known as thermal runaway. The self-distortion of transistor takes place. The self-distortion of transistor takes place. That is called as thermal runaway. Yeah. Which of the following method of biasing provides the best operating point suitability? This question how many times it is repeating, just you see here, because of the such a importance is there. Which of the following biasing provide best operating point stability? Self bias will provide the best operating stability. Self bias will provide. Right. Next question. What is the next question? If alpha is equal to 0.98, the ratio of IC naught by IC naught. If alpha is 0.98, the ratio of IC naught by IC naught. You know very well. What is the relation? ICE naught is equal to 1 plus beta times of IC naught. 1 plus beta times of IC naught. That is 1 plus beta means what you write? Alpha by 1 minus alpha you can write. Alpha by 1 minus alpha. If you simplify this one, IC naught. What is that? 1 minus alpha plus alpha divided by 1 minus alpha. This alpha gets cancelled. 1 by 1 minus alpha. 1 by 1 minus alpha. So, your IC naught by IC naught. IC naught divided by IC naught is equal to 1 by 1 minus alpha. 1 by 1 minus alpha. Alpha is given as 0.98. So that 1 minus 0.98. Okay, ma? Screen is not clear, huh? Jilani once check a screen and they told. Okay, ma, what is the answer? Answer is 50. Followed all of you? See here, the next question. What is the next question? When CE transistor operates, IC is equal to VCC by RC. IC is equal to VCC by RC. Then it is said to be a cutoff region, active region, saturation region, class A amplifier. Okay, right. Tell me what is the answer? When IC is equal to VCC by RC means we are selecting the operating point is here. And the operating point is here means which is a saturation region. This one is a saturation region. Okay? Saturation region. How both? What is both, ma? When you select the operating point is here, which is saturation. When you select the operating point is here, cutoff. When you select the operating point here, that is active. This is active. So this is what transistor characteristics. Middle of the load line is a active region. This one like this. Right, okay? Next question. The probable biased transistor amplifier VCE should be forward biased about VCC by 2, reverse biased equal to VCC. Basic electronics paper is this. We are talking about the only basic electronics. The topic itself is a basic electronics. After completion of basic electronics, we will discuss some other topics. Okay, ma? So this is a very, very important question. Probability of biased transistor operating point is to be the middle of the load line. I told you na VCC by 2. It should be operated at a VCC by 2. Very good. Very good. Next. The process of making a operating point is stable is called biasing, stabilization, thermal runaway, none of this. This is a little bit careful observing question. The process of making operating point is stable is called what answer? Stabilization. The answer is stabilization. Right, ma. Right. Next. Yeah. So this would be the very, very, very important question. As per my knowledge, this question is given number of times in the competitive exams. This question is given in the number of times in the competitive exams. To avoid thermal runaway, the condition is very, very important question, ma. Already one point related to that I told you already. In the similar pattern, now one more question is here. What is the condition? Very important question. See all of you. VCE should be less than or equal to VCC by 2 to avoid thermal runaway. Don't forget this question, my dear students, which is a very important question. Yeah. Less than or equal to VCC by 2. Now see here. To have better stability, the RB by RE ratio, RE ratio in cell bias circuit is smaller, larger, very large, none. Always RB value should be small. RB value should be small for better stability. RB value should be large for better stability. These two conditions we have. So small by large value, no doubt it should be small value. It should be a small value. Clear all of you? Next question. What is the next question? The most important effect of temperature rise in CE connected transistor is the increasing of AC current gain, output resistance, power gain, IC naught. Where is the most effect of temperature? Tell me what would be the answer for this. The most important effect of temperature rise in CE transistor, increasing of AC current gain, output resistance, power gain, IC naught. What's the answer, ma? ICE naught will be the answer. ICE naught will be the answer. Okay, ma? Right? Because I already told you, na, IC naught is equal to 1 plus beta times of IC naught. Thermal runaway problem will take place because of this one, thermal runaway problem. So that's why that's question. The operating point of a transistor changes, its H parameter values are. Operating point is changes, its H parameters are. Tomorrow is the ESET exam. Don't attend for this class. Please go through your preparation. No. It is not for ESET students. Please, your kind information. Those who are ESET students in this class, please leave the class and go through your preparation. Don't attend for this class, ESET students. My dear students, please. Once you try to revise all the questions what are available for you according to your syllabus. Tomorrow exam you should not attend, please. By mistake they may send the message for you. Okay, KPTCL you have to attend. Tomorrow is not exam for KPTCL, na? JE means junior engineers. So, if the operating point of transistor changes, its H parameter values also changes. H parameters values changes. It will come, Amma, it will come. Okay, ma, okay, right. The quiescent state of a transistor implies. The quiescent state of the transistor implies. Quiescent state means no input signal. DC. Quiescent state is nothing but a DC. DC, no input signal. Next two. The stability factor of a collector to base bias S is equal to 1 plus beta by 1 plus beta into 1 plus beta divided by 1 plus beta into RC by RC plus RB. This already I written. This formula I already written. Basic formula for stability factor is 1 plus beta by 1 minus beta DIB by DIC. This is the correct answer. Stability factor. Stability factor. Next. The zero signal values of IC and VC is nothing but operating point, Q point and a quiescent point. All the above. Zero signal values of IC and VC is nothing but all the above. Quiescent point, Q point, operating point. Transistor biasing represents. Transistor biasing represents dash conditions. AC condition, DC condition, both AC and DC condition. What is that? Tell me what is the answer? Transistor biasing represents DC na? Only DC. Next. The stability factor of a collector to base bias is dash that of fixed bias. Stability factor of a collector to base bias is less than that of fixed bias. Here your stability factor is less because it is better biasing than fixed biasing. It is a better biasing than fixed biasing. Stability factor of a collector to base bias is less than the fixed bias. The purpose of using emitter bypass capacitor in self bias is the purpose of using emitter bias. So, for example, if we have a transistor is here, this is the transistor. We have a emitter resistor is here, and a capacitor is connected like this. Capacitor is connected like. Why emitter bypass capacitor is used? Yeah, you have to answer. Yes, ma. This topic is useful for KPTCL JE. Exactly, which is useful. So it will bypass the AC signal like this. AC cannot pass to avoid this one AC. Avoid the loss of AC signal. That is what the answer is. Next. In emitter bias method of feedback is used for stabilization. Current series feedback, current shunt feedback, voltage series feedback, voltage shunt feedback. So emitter bias means you are using biasing is here. You are using the biasing resistance RE is here. In which configuration? In a common emitter configuration. If you are using this one, the signal is not attached to output node. Hence it is a current feedback. What is that? What is this type of biasing? Emitter bias method is of a feedback is used for stabilization of this is a current series feedback. Because you are taking output is here, the signal is not touches to the output node, hence it is a current feedback. This feedback is not given to the input signal, hence it is a series feedback, current series feedback. It is not emitter follower circuit. It's not a emitter follower circuit. Next, rectifier is used to convert AC to DC. AC to DC. What is their very simple question? Rectifier will convert AC to DC. Next, the ripple factor of half wave rectifier 1.21. The ripple factor of half wave rectifier is 1.21. Next, the peak inverse voltage of a half wave rectifier, PIV of half wave rectifier is VM. PIV of half wave rectifier is VM. The peak inverse voltage of a full wave centered up rectifier is 2 VM. Peak inverse voltage of a full wave centered up rectifier is 2 VM. Okay. Next, the efficiency of a full wave rectifier. The efficiency of a full wave rectifier is 81.2%. Is 81.2%. Very simple questions. The peak inverse voltage of a bridge rectifier is VM. Bridge rectifier is VM. Center tap transformer is 2 VM. Half wave rectifier is also VM. Half wave rectifier is also VM. Right. Next, the diode used in the voltage regulator is Zener diode. The diode used in the voltage regulator is, what is that? Zener diode. Next, the ripple factor of an inductor filter is RL by 3 root 2 omega L. RL by 3 root 2 omega L. RL by 3 root 2 omega L. What is that? The ripple factor of a inductor filter is. Next, the primary function. The primary function of a rectifier filter is to. The primary function of a rectifier filter is suppress the odd harmonics, remove the ripples, stabilize the output DC level, minimize the input AC variations. Tell me mainly what is that? Ripple quantity can be reduced. Mainly it will reduce the ripples. It will reduce the ripples. Next, in a full wave rectifier, the diode conducts for The diode will conduct for 1/2 cycle. One diode will conduct for 1/2 cycle, other diode will conduct for another half cycle. So alternative half cycles may be the answer. Alternative half cycles. Alternative half cycles. The ripple frequency of full wave rectifier. Sometimes the question they may ask you output frequency also. Ripple frequency or output frequency of full wave rectifier is 2FO. Twice the supply frequency. Very important question, Amma. They will make as a problem also. This question they will give as a numerical problem also. Input frequency they provide with 50 Hz. What would be the output frequency? What would be the ripple frequency? Something like that they will ask you. Twice the supply frequency. Twice the supply frequency. Next. The inductor filter is more effective only when the load current is. Load current is higher because inductor filter ripple factor is directly proportional to RL. So RL value should be less. RL value should be less means your load current should be more. Load current should be more. This I told you in your class also. In inductor filter, so load current should be high. We discussed now this question already in the class. Because of asking the load currents. Next, what is the ripple factor for a capacitor filter? 1/4√3 FC into RL. 1/4√3 FC into RL, because ripple factor is inversely proportional to RL in the case of capacitor filter. In the case of capacitor filter. This formula also I told you in the class itself. As compared to center tapped full wave rectifier, the bridge full wave rectifier dominant advantage of. As compared to center tapped full wave rectifier, the bridge full wave rectifier has dominant advantage of highest current carrying, low PIV, low ripple factor, higher efficiency. Low PIV, lower PIV, because in center tapped transformer we have a 2 VM. In bridge rectifier it is VM. It is bridge rectifier, it is VM. Yeah. Next question. If VM is the peak value of the applied voltage in a half wave rectifier with a large capacitor across the load, then the PIV is VM is the peak inverse voltage applied of the half wave rectifier with a large capacitor across the load, peak inverse voltage is. Half wave rectifier with a capacitor filter. Actually for a half wave rectifier the PIV is VM, but half wave rectifier with a capacitor filter is 2 VM. Even though it is a half wave rectifier, 2 VM is the answer. This is only for capacitor filter. Half wave rectifier with a capacitor filter. Half wave rectifier with capacitor filter. Next, a rectifier is delivering a DC current of 10 milliamperes to a load of 1 kilo ohm while drawing a current of 20 milliamperes from AC supply. Its rectifier efficiency is. A rectifier delivering a DC current of 10 milliamperes, load of 1 kilo ohm while drawing a current of 20 milliamperes from AC supply. Its rectifier efficiency is. What is the rectifier efficiency formula? Efficiency formula means output power by input power. That is IDC square divided by IAC square. Diode, we can assume the diode is ideal. RL, both the cases you are getting RL. So what is that? 10 by 20 whole square. 10 by 20 whole square. 1 by 2 whole square is 0.25. Nothing but 25%. Very nice question. Very nice question it is. People may answer 50% because 10 by 20 they will write. Be careful. IDC by IAC whole square. Because efficiency formula is IDC square into RL upon IAC square into RL plus RF. RL plus RF. The inductor filter is suitable for dash load and the capacitor filter is suitable for dash load. I already told you that. Inductor filter is suitable for high loads and the capacitor filter is suited for low loads. Load means load current. Load means load current because in inductor filter the ripple factor is directly proportional to RL. In capacitor filter ripple factor is inversely proportional to RL. But they are asking load. Load means current. So ripple factor is inversely proportional to load current. So ripple factor always should be small. Current should be high. That is what based on that. This condition. Okay, ma? In LC filter, the ripple factor is independent of the independent of the load resistance. Increases with load current, increases with load resistance, decreases with load current, remains constant with load current. This is the right answer. Because of L and C both together is oppositely compensating. Oppositely compensating. Next two. If the AC input voltage of half-wave rectifier is 400 by root 2, that is VRMS, then the diode PIB rating is which rectifier? Half-wave rectifier. What would be the answer? In half-wave rectifier, VM is the answer. VM means 400 by root 2 is the RMS value into root 2 we have to make for maximum value. Root 2 gets cancelled, 400 volts will be the answer. 400 will be the answer. Next two. Next two. The rectifier which is most suitable for high voltage rectification. The rectifier which is suitable for a high voltage rectification. Tell me last question. For this topic it is last question. For high voltage rectification. What is that? Bridge rectifier is best suitable. Bridge rectifier is best suitable. Next one. Okay, ma? This is the idea about this particular rectifiers and biasing. The next topic we will take the feedback amplifiers. Yes. This is feedback amplifiers and power amplifiers. The topic is feedback amplifiers and power amplifiers. Okay, ma? Right. Shall I continue or not? Right, ma, right. Okay, ma. If you have patience, I will tell you. Otherwise, how many students are there? Only one. Okay. Okay, I will continue. For me, no problem. Only I am thinking about you. Okay. So here also we have nearly 50 questions we are having. Right, Sama? See the question. In a positive feedback amplifier, the phase difference between an input signal and a feedback signal is. In a positive feedback, yeah. That's why I am telling all the questions. Actually, KPTCL students are not lagging. They are already more aware of this topic. Other students may be in a little confusion, but KPTCL preparing students are very confident with this subject. In positive feedback, what happens, Amma? Our input signal should be feedback signal, both should be in phase. Both should be in phase, so that 0 degrees is the right answer. 180 degrees phase for negative feedback. 180 degrees phase is for negative feedback. Okay. Joshna, right? Next. In negative feedback amplifier, the phase difference between an input and output feedback signal is. Just now we discussed this point. This point we discussed just now. What is that? For positive feedback 0, for negative feedback it is 180. For negative feedback it is 180. I told you already. Next. The positive feedback reduces because of the positive feedback reduces stability, distortion noise, bandwidth. Bandwidth. Tell me what is answer? What is the answer for this? Generally, because of positive feedback, distortion is more, noise is more, stability is less. Whatever the advantages are there for negative feedback, which is reverse for this positive feedback, you have to think of it. Bandwidth will decreases. All of you, my dear students, you have to know that what will happen for negative feedback. Now, because of negative feedback, what will happen? So you have to know it. What are the advantages of negative feedback? What are the advantages of negative feedback? The advantages of negative feedback is stability is more, better stability. Distortion decreases, noise decreases, bandwidth increases. Bandwidth increases. And input and output impedances can be modified according to our requirements. The input impedance can increase, input impedance can decrease. Output impedance can increase, output impedance can decrease. All are possible like that. Yes. But here the question given is a positive feedback. Positive feedback is the opposite to the negative feedback. That's why the suitable answer is bandwidth for this. Bandwidth for this. Next. Right, Amma. The negative feedback increases instability, distortion, noise, bandwidth. Because of it, just now we discussed, because of negative feedback, stability better, distortion decreases, noise decreases, bandwidth increases. What is asking? Which is increases? Bandwidth is increases. No, yaar. Here, instability. Stability is increases, instability decreases. Stability is different, instability is different. Isn't it not? No, don't fix like that. Depending upon the question, you have to answer. Sir, can I fix the bandwidth? Don't fix like that. What is the question given? Read carefully. Before going to the examination, you should know that what are the advantages of a negative feedback. Only one disadvantage in the negative feedback is gain will reduces. Gain is reduces. Right? Next. The negative feedback decreases bandwidth, noise, stability and none. Very easily you have to answer. See how many questions are. Gain is not available here. You have to answer. Which is decreases. Only 5 points. If you remember, easily you can answer it. Yes, exactly. Noise is reduces. Right, ma. Noise is decreases. Distortion is decreases. Increases the stability. Increases the bandwidth. Noise decreases. I hope you understand this. Next. So in a negative feedback decreases bandwidth. In a negative feedback bandwidth they should not ask decreases. This may be that. It should not be like this. In a negative feedback, which statement may be the correct? Your bandwidth is increases 1 plus A beta times multiply. You can have. Because of negative feedback, bandwidth increases by 1 plus A beta times. One plus A beta because of bandwidth is increases. Next. In a current series feedback amplifier, the voltage gain is. See, once if you are using the feedback, if you are using negative feedback, the gain will decreases automatically. Once if you are using a negative feedback means, we know that gain is decreases. That's why this is the answer. Gain is decreases. Only important points you try to remember. Because of negative feedback, stability better, noise reduces, distortion reduces, bandwidth increases. Only disadvantage is gain decreases. Next, in a negative feedback amplifier, the stability changes by a factor of A beta, 1 by A beta, 1 plus A beta, 1 minus A beta. Stability changes by a factor of. Tell me what would be the answer for this? Yes, ma, yes. 1 plus A beta times. Any factor increases or decreases by a factor of 1 plus A beta in the case of feedback amplifiers. In the case of feedback amplifiers. Next, a series derived shunt feedback, otherwise called as feedback amplifier. So see here, series derived, you are taking from here, this is shunt feedback, here is given. Series means voltage, because the terminal is not touches. Shunt means what? Shunt means what? If the input signal is connected to the input terminal, that is called shunt feedback. Shunt feedback means what is the mixing we are giving? Current mixing we are giving. Current mixing we are giving. So what is the name of it? What is the name of it? This is the series derived means which one is the current. It is not touches to the output node. It is touches to the input node. It is a shunt. That's why current shunt we can call. We can call as a current shunt. Next, the feedback factor beta for voltage shunt feedback amplifier is. Voltage shunt feedback means what is the amplifier? Output is voltage. Input is also, what is that? Shunt mixing. Shunt mixing means what mixing? Current mixing. Input is current. So output voltage by input current. So we have a beta. Beta is equal to output by input. Output is voltage. Shunt mixing means current mixing. This is our feedback amplifier. Output is voltage. and this is the feedback factor beta. Feedback factor beta, shunt means current. Current by voltage. Current by voltage. This is the voltage you are taking, this is the current. So IF by V naught. IF by V naught. Beta is equal to IF by V naught. Okay, ma? Next question. Next question is what? The current series feedback amplifier is also known as dash amplifier. Current series means output is current. Output is current. Input series means voltage mixing. Voltage mixing. Input is voltage mixing. Because series mixing is nothing but voltage mixing. Output is current. Output current by input voltage. Output current by input voltage is a transconductance amplifier. Is a transconductance amplifier. Whatever here is available, which is as a output, and whatever this is there, it is a input. Output current by input voltage. Yeah. The upper and lower 3 dB frequencies of amplifier with a negative feedback is. I think this question is asked doubt. Somebody, this question is asked me as a doubt. Everybody is getting video, ma. Problem may be for you, Josna. Who asked this question as a doubt for me? Okay, ma? So because of the negative feedback, what happened to bandwidth? The bandwidth is increases. Bandwidth increases means your F2 dash upper 3 dB frequency increases, lower 3 dB frequency decreases. Upper 3 dB frequency, upper 3 dB increases, lower 3 dB decreases. Increases and decreases. This will be the answer. Pooja, this question you asked me doubt in the long back. Okay, ma? Everyone is understood? How this is? The upper and lower 3 dB frequencies on an amplifier with a negative feedback. Because of negative feedback, our bandwidth will increases like this. Bandwidth will increases. Bandwidth increases means your lower 3 dB frequency will becomes left side and upper 3 dB frequency will goes to right side. Okay, no problem. But Seema, the same thing in the multi-stage amplifier, it is a different concept. If you go for multi-stage amplifiers, if the number of amplifiers are cascaded, bandwidth will decrease. Bandwidth will decrease means F2 dash is decreases, F1 dash is increases. Don't confuse for that question to this question. Multi-stage amplifier concept is different and the feedback amplifier concept is different. Whatever I explained here, the same concept will be reversed for a cascading of multi-stage amplifiers. Cascading of multi-stage amplifiers. Right? The feedback factor beta of a current shunt feedback. Current shunt feedback. Your beta factor is like this. Your beta factor is like this. You are taking current here. Current is here. Shunt mixing. Shunt mixing means current mixing. So this is the current. This is also current. IF by I naught. Feedback factor beta is IF by I naught. Okay, ma? IF by I naught. Output by input will give IF by I naught. Next, the emitter follower here is an example of dash feedback amplifier. Emitter follower here, it is a very important question, amma, which is a voltage series feedback. Emitter follower here is a voltage series feedback. I told you in your notes also is available. Emitter follower here is a what feedback? Voltage series feedback. Next, this is a power amplifier questions. Crossover distortion occur in dash operation. Class A, class B, class C, class AB. Where is that? Tell me the answer. See, crossover distortion is present in the class B amplifier. Crossover distortion is eliminated in the class AB amplifier. The crossover distortion is eliminated means you have to answer class AB. Crossover distortion is present means you have to answer class B. Clear, ma? All of you? Crossover distortion present means class B. Crossover distortion is eliminated means class AB. Be careful about that point. Okay, right. Next. The value of Ri and R0 for an ideal transconductance amplifier. Ideal transconductance amplifier. What is the next transconductance amplifier? Transconductance amplifier means GM. GM is equal to I naught by VL. I naught by Vn. From the output you are taking current. Current sampling. Current sampling. Input voltage means series mixing. Series mixing. I told you one shortcut. When voltage and shunt will comes, you write down decreasing. Other than that, it is increasing. What happened? Current is infinity. Series mixing is also infinity. So D is the answer. Infinity, infinity. Voltage series feedback as provided in emitter follower, tuned amplifiers, crystal oscillator, Hartley oscillator. Voltage series feedback is present in the emitter follower circuit. Emitter follower circuit. Emitter follower circuit. Next, push-pull amplifier offers less distortion and more output power, more distortion and more output power, more distortion, less output power, less distortion. Push-pull amplifier, less distortion and more output power. This will be the answer. Okay? Right, Amma? Next, the transistor with 85% of efficiency likely to be which is having a higher efficiency. Class A, Class B, Class C, which is having higher efficiency. Class C is having higher efficiency. Class C is having higher efficiency around 85%. What is the efficiency of a Class A amplifier? 25 or 50. What is the efficiency of a Class B amplifier? What is the efficiency of a Class B amplifier? 78.5%. What is the efficiency of a Class B amplifier? Approximately 65%. So what is the answer? Class C amplifier will have efficiency 85%. All the amplifiers efficiencies are covered. Dash operation has almost no collector current with no signal is applied. No signal is applied, no collector current. Because your operating point for Class B configuration is selected here. So that's why no collector current means this one, Class B. Class B, right. Next, A and AF are the gain that without and with negative feedback. The feedback function beta is, you know already, negative feedback. AF is equal to A by 1 plus A beta. That you have to simplify in these terms. That becomes as Beta will becomes as 1 by AF minus 1 by A. 1 by AF minus 1 by A. Okay. Next, the current shunt feedback, the input and output impedances are current shunt. Output is current. Input shunt mixing means current mixing. Shunt mixing means what? Current mixing. Current mixing. You are taking output is what sample? Current sample. You are giving input is current mixing. Then you tell me. Shunt means I told you decreases, current means increases. But this comes in the output side, this comes in the input side. Output side is what happened? Increases. Low and high. Low and high. For this opposite we have to take. No, no like that. Current shunt. You have to write as shunt and current. I told you now, whenever shunt and voltage will comes, it is decreases. Current and series will get increases. Shortcut formula I told you. So decreases and increases. Low and high. Low and high. Okay. Right. Next. An amplifier has a voltage gain of 100. To reduce the distortion 10% of negative feedback employed, the gain of the amplifier with feedback. Gain of the amplifier with feedback means 100 divided by A by 1 plus A beta. 1 plus 100 into beta. Beta is how much? 10%. 10% means 0.1. 100 divided by 11 is the answer. 100 divided by 11 means 9.09. 9.09. Next. Class B push-pull amplifier suffers from crossover distortion. Already we discussed. Crossover distortion. Class B problem is crossover distortion. That can be eliminated by class AB. Negative feedback amplifier results in more gain, more bandwidth. Wrong. More gain is wrong. Less gain, more bandwidth. This is the right answer. Gain is decreases, but bandwidth is increases. Because of negative feedback, gain will decreases. Gain decreases, bandwidth will increases. Next. Ideal transconductance amplifier. Already this question has came. Input resistance is infinity, output resistance also infinity. Transconductance amplifier. Voltage amplifier, input impedance infinity, output impedance 0. Current amplifier, opposite to the voltage amplifier. Trans resistance amplifier, 0, 0. Trans resistance amplifier. Next. If the maximum dissipation capacity of a transistor is 5 watts in a class A amplifier, the maximum AC power transistor delivered can be what configuration? Class A configuration. In class A configuration, what happened? Your maximum power dissipation capacity is 5 watts. Class A amplifier. AC power is how much? Only 50% is the efficiency. So that's why 2.5 you can answer. 50% efficiency na? So that 2.5 you can answer. 50% efficiency. Next. Which one of the following power amplifier has maximum efficiency? Which one of the following power amplifier has maximum efficiency? Class C amplifier. Which amplifier? Class C amplifier. That already we discussed. 80 something, 80. The voltage gain of an amplifier without feedback and with feedback are 120. Then percentage of the negative feedback, beta, they want to calculate. So what is AF is equal to? A by 1 plus A beta. AF is equal to A by 1 plus A beta. What is AF? 10. So not 10, 20. 20 is equal to 100 by 1 plus 100 into beta. Beta you have to calculate from this. Beta you have to calculate from this. What is the beta value for this? The beta is 4%. If you calculate that, you are going to get that 4%. Right, Amma? Next, if 1 plus A beta is greater than 1, the type of feedback is 1 plus A beta is greater than 1, it is a negative feedback. If 1 plus A beta is less than 1, is a positive feedback. Okay, right. 1 plus A beta. Next, harmonic distortion of an amplifier with a negative feedback. Because of feedback, whatever the harmonic, it will be reduces. So distortion will decreases. Distortion will decreases. Whatever the type of feedback. See here. The turns ratio of a transformer is 15:1. If the load is 8 ohms is connected across its secondary, what will be the effective resistance looking into the primary? They are asking RL dash. RL dash is equal to RL by K square. RL dash is equal to RL by K square. So what is your K value? Your K value is how much? As per this given, 1 by 15. 1 by 15. Actually, he has to give transformation ratio clearly. He should not mention turns ratio. They have to give transformation ratio here. 1 by 15. So what is your RL value? 8. 8 divided by 1 by 15 whole square. RL dash K square. 8 into 15 whole square. 8 into 15 whole square. How much you are going to get it? What's the correct answer, ma? $225. 8 into 225. So 1.8K. The procedure is this one. RL dash is equal to RL by K square. 225 into 8, how much you are getting? B is the answer. 1800 you are getting. 1800 means 1.8 only, na? Next, the main use of Class C amplifier is an RF amplifier as a stereo amplifier in communication systems distortion generator. Actually, RF amplifier is a radio frequency, Class C amplifier. Class C amplifier is a radio frequency amplifier. Both it is useful for both. It's useful for both AE and JE. Next, the term AV of an amplifier is called. The term AV. Actually, they want to give AF. I think AF they have to give. Otherwise, what is the question given? So actually, A is nothing but a gain without feedback. Gain without feedback. AF is nothing but a gain with feedback. With feedback. A beta is nothing but a loop gain. A beta is nothing but loop gain. 1 plus A beta is nothing but a desensitivity. 1 plus A beta is nothing but a desensitivity. 1 by 1 plus A beta is nothing but sensitivity. These are all the notations we have to use it. If they given AF, your answer may be gain with feedback. If F is not given, gain without feedback we have to answer. A beta is nothing but loop gain. All the conclusions are given for you. Next, when power output of an amplifier is doubles, the increasing of its power level in decibels is. Double the power means 3 dB, 3 decibels. Half power or double the power, 3 decibels. Half power or double the power is a 3 decibels. 3 decibels. 3 dB frequencies is nothing but a half power frequencies. 3 dB frequency is nothing but a half power frequencies or double power frequencies. A Class B amplifier is biased just at cutoff, nearly twice the cutoff at midpoint of the load line saturation. For Class B amplifier, operating point is selected here. Just at cutoff. Just at cutoff. Next. If the input and output resistance of an amplifier increases with a negative feedback, the resulting circuit should have input resistance increases, output resistance increases. It means that current series feedback. Voltage and feedback both are decreases. Current series feedback both are increases. Voltage series, output decreases, input increases. Current center, current means output increases, input decreases, like that. See here, you may be studied resonance also. When you have a power is here, power becomes half. These frequencies are called what? 3 dB frequencies. These frequencies are called 3 dB frequencies. When power is coming from 10 to 5 watts or power is going from 5 to 10 watts, both the values will be equal to 3 decibel frequencies. Power, because decibel formula is 10 log base 10 output power by input power. What you are given? Double the power, 2 by 1. Log base 10 2 value is 0.3. 0.3 into 10 is 3 dB. 10 into 0.3, that is 3 dB. Okay, my dear student. The maximum efficiency of class B push-pull amplifier, already we discussed, 78.5%. Maximum efficiency of class B push-pull amplifier. Next, which class of amplifier has the lowest efficiency? Class A amplifier. Only 25% or 50%? Only 50% or 25%. Next, the gain of the amplifier with positive feedback, A by 1 minus A beta. A by 1 minus A beta. A by 1 plus A beta is for negative feedback. A by 1 minus A beta is for positive feedback. Positive feedback. Next, an ideal voltage amplifier. Voltage amplifier means voltage series feedback. Voltage series feedback. Because of voltage, output is decreases. Because of series, input is increases. It is infinity, it is 0. Where is that answer? You have to choose it. Infinity and 0. Infinity and 0. Next, which of the following statement is false? Push-pull signals are equal and opposite in phase. Class AB operation cannot be used for push-pull power amplifier. A push-pull output transformer has a center tap primary. All the above. Tell me what would be the answer for this. False statement. Class B amplifier, class AB amplifier both are same. This can be used for push-pull configuration also. Cannot be is not a wrong. Can be used for push-pull also. Complementary symmetry amplifier. One NPN transistor, other one is PNP transistor. That's why it is called complementary symmetry. One NPN transistor, other one is PNP transistor. Next, third harmonic of 300 edges. Third harmonic means 3 into whatever the frequency given. That is 900. That is 900. Third harmonic. Third harmonic frequency. Next, which of the following coupling generally employed in power amplifiers? In power amplifier, which of the following is generally used? Transformer coupled. What is that? Transformer coupled. Transformer coupled is preferred. Next, the maximum efficiency of a class A power amplifier with a resistive load is. The maximum efficiency of a class A amplifier with a resistive load is. Resistive load means 25% only. Resistive load means 25% only. Instead of resistive load, suppose a transformer is given, then you can answer 50%. If it is a resistive load means 25, if it is a transformer means 50%. 50%. Likewise. Next. Yeah, same question is repeated here. The maximum efficiency of class A power amplifier with a transformer load, that only I discussed now, that is 50%. That only we discussed, the same question as repeated. Without this question also I explained for you. Next. In class A amplifier with a sinusoidal input, the collector current flows for a Full cycle, completely. Class A amplifier means full cycle. Class B means only half cycle. Class C means less than 180. Less than 180 like this. This is for class A, this is for class B, this is for class C. 360 degrees, 180 degrees, less than 180 degrees. Yeah. Total harmonic distortion formula. D is equal to square root of D2 square plus D3 square plus D4 square. This is also important formula. Total harmonic distortion. Okay, ma? The next one. In a class C amplifier with sinusoidal input, the collector current flows for class C amplifier less than half cycle. Less than half cycle. I told you now just now. All the similar related things. This is about your what is that? This feedback amplifiers and our amplifiers. What are the topics we discussed? Power amplifier, feedback amplifiers, rectifiers, transistor biasing, JFET, FET and BJT. All the topics today we covered. Tomorrow also I will take the class. What is the subject? I will intimate tomorrow. What, Venkat Gowda? You are since Brahman. Just check it. So operational amplifier is there. Can we discuss operational amplifier? No. Everybody can watch this video. It's a public. Okay, ma, we will take a break, a small break. Yeah, sure. Okay, ma. So take a 15 minutes break, amma. I will start the class at 7:45. I will take the class at 7:45.